Hello everyone, I'm Kristiyan, founder and CTO of BetterDB. Today I want to talk about something I've been thinking for a while. What developers and operators actually need from in-memory database tooling. And I want to be upfront. This isn't a product talk, this is a landscape talk, so let's just get right into it. Think about the last time something went wrong in production. Not a code bug, a database issue. Latency spike, memory sealing, something just started being slow. If your database was Postgres, you had pgstat statements, you had query plans, execution counts, the evidence was sitting there waiting for you. If your database was Redis or Valky, you had a CLI, some info output, and whatever Prometheus happened to catch in the last 15 seconds if you bothered to actually set it up. That gap is what I want to talk to you about. All of this isn't accidental. In-memory databases are operationally opaque by design. Speed is the product. Data lives largely in RAM. Hybrid solutions like Redis Flex are starting to change that, but the entire operational model was built around the assumption that you don't need to look inside very often. That assumption held when these systems were simple caches in front of a database. It doesn't hold anymore. Redis and Valky are now central infrastructure parts. Session management, rate limiting, PubSub, vector search, AI inference serving. When they go wrong, things go wrong everywhere. And here's the thing. Every other part of the modern stack has mature observability. Your application has distributed tracing. Your infrastructure has Datadog or CodeWatch. Your Postgres has explain plans and pgstat statements baked in. Your memory database has what exactly? Let's audit what actually exists, and let's start with the simplest possible thing. The CLIs. Valky CLI and Redis CLI. Universal, almost zero dependencies, always available. It's the first tool anyone uses and the last one they fall back to when something is on fire. It's the easiest thing to just connect to a database, check some data in it, or generate a ton of information and save it. For exploration, it's also excellent. The problem is it's entirely stateless. Every invocation is a snapshot of right now. No history, no correlation, no trending data, no context of what has happened before that. In cluster mode, it gets even worse. You connect to a single node, you get moved redirects for keys that live elsewhere, and getting a cluster-wide picture means stitching together output from every single node manually and then trying to figure things out. Next, we actually have the graphical user interfaces, your Redis insights and Valky admins. These give you a visual interface, key space browsing, dashboards, and increasingly AI chatbots to help you with debugging. They lower the barrier to entry significantly, but both have a ceiling. Redis Insight, for instance, save database analysis reports, memory usage, key distribution, but they are manually triggered and cover key space structure, not the actual operational behavior. Valky admin stores some command log and hotkey data locally via Electron, which is used to bundle both of these applications into desktop apps, which is a step forward, but it's a flat file storage. No query API, no cross-metric correlation, nothing deeper than that. Both tools, by their own admission and description, sit between the ad hoc CLI usage and long-term metrics. They are observational tools, not investigation tools. The third tier is where most teams actually get their time series data from, Prometheus, and specifically Redis Exporter by Oliver 006. Well maintained, widely adopted and deployed, integrates with every Grafana dashboard you've seen. For aggregate metrics, it's solid. Memory usage over time, hit rate trending, connected clients, replication WAG. This is a real value and it works. But there are two blind spots that are worth naming explicitly. The first, it works at the info level. Info gives you aggregate numbers. It tells you that your instance consumed 800 milliseconds of CPU over the last second. It does not tell you which commands actually consumed it. You can see that your P99 latency spiked. You cannot see from the exporter alone whether it was a call to a giant JSON file, a large hash, a keys command someone accidentally ran in production, or a wall script that got expensive somehow. The exporter sees the outcome, not the actual cause of it. The second blind spot is structural, and it matters more and more as time goes on. This is a Redis exporter, as you can guess from the name. It was built against Redis's info surface. The sections, the fields, the metrics that Redis exposed. Valkey has added entirely new primitives that don't exist in Redis at all. Command walk, SWOT stats, per thread, IO metrics. None of these appear in Redis exporter output because they weren't there when it was written. You're running a Valkey instance with a significantly richer observability surface than Redis ever had, and your exporter is blind to most of it. As Valkey continues to diverge, this gap will only continue to widen. And then there's APM. Datadog, New Relic, Dynatrace, and probably a dozen more that I'm missing on this slide. They all have Redis and Valkey integrations, and they are genuinely useful, but they are instrumenting the client side. They see the calls that your application makes to Valkey or Redis. Here's the subtle but very important distinction. Client-side latency and server-side latency are not the same number. Network, serialization, client library overhead, all of that is in the client measurement. If you want to understand what's happening inside the Valkey instance itself, APM alone won't get you there. So here's the honest summary. The ecosystem covers the easy cases reasonably well. Development, exploration, capacity monitoring, these are very well solved problems. The hard cases are actually production incidents, latency regressions, cluster hotspots, and where everything gets thin. And those are exactly the cases where the cost of not having a good tooling is actually the highest. I want to take a step back and explain why I think this is worth talking about right now specifically. When Redis changed its license and moved away from open source just for a little bit, within weeks, the Linux Foundation and a group of Redis contributors forked the code base and created Valkey. That was less than 2 years ago. What that means is that Valkey is starting fresh, relatively, not just on the code base, but on the entire ecosystem around it. The tooling that existed was built for Redis. Some of it still works fine, but it wasn't built with Valkey's operational primitives in mind, simply because those primitives didn't exist yet. This is actually a rare moment. The database is ahead of its tooling. The signals Valkey is generating are better than Redis at the moment, but the ecosystem hasn't caught up yet. And that's a gap, but it's also an opportunity. Every observability tool, every monitoring integration, every IDE extension that gets built in the next year or 2 or 3 is actually going to define what Valkey operations look like for the next decade. The decisions being made right now about which signals to capture, how to persist them, and how to surface them to developers and operators, those decisions actually matter. Here's something that I think is underappreciated. The data you need actually does exist. Valkey is generating it consistently. Slow walk, command walk, latency history, client list, it's all there. The problem is it's ephemeral. All of this lives in the ring buffer style. When the buffer fills, all the entries are evicted. When the server restarts, everything is gone. This is a design decision and not a bug. In-memory is fast exactly because it doesn't persist things it doesn't have to. However, this also creates a very specific and painful problem. Let me make that concrete with a scenario that anyone who has operated Redis, Valkey, or basically anything in production at scale will recognize. It's 3 a.m., you're alerting fires, P99 latency has gone from 2 milliseconds to 400 milliseconds. Your application is essentially degraded. Customers may already be affected. What happens? The on-call engineer gets paged, they log in, they look at Grafana, they can see the spike in the charts, they can see memory is elevated, they can see connected clients are higher than normal, but they can't see why. So they make a judgment call. Maybe they flush a key they suspect is hot, maybe they adjust the eviction policy, maybe they just restart the instance. The spike goes away, system stabilizes, the engineer goes back to sleep. Now, it's 9 a.m. The team gathers for a post-mortem. They want to understand what happened so it doesn't happen again. They have real questions. What commands were executing at the time of the incident? Which clients were connected? Was it a specific service? Was it a specific job? Was there a hotkey causing contention? Was the instance CPU bound or was it IO bound? Did the problem start gradually or was it sudden? They open Swalwalk. It's empty. It rolled over during normal traffic in the hours after the incident. The default Swalwalk size is 128 entries. I mean, you can change it, but for the sake of the example, by 9 a.m., all of those 128 slots have been filled and overwritten multiple times. They check command log. Same story, last 128 entries, all from the morning's normal traffic. Client list shows you the current connections, not what was connected at 3 a.m. So all the evidence is gone, not because anyone deleted it accidentally, not because the system failed, because that's how it works. Ephemeral by design. You're doing forensics with no crime scene, and the post-mortem turns into guesswork. And this isn't one story. This usually can play out in three different ways. One is something similar to what I just described, but it can also happen in a different way. Imagine it's a next day discovery. Imagine it's a smaller company, they don't have 24/7 support, no dedicated database in admin or engineer, so the 3 a.m. spike is actually a Slack message that's noticed during the 9 a.m. stand-up, and by then all of the evidence is already gone. The second case is quieter and often more damaging. A bioshock, a suboptimal command pattern, runs unnoticed for days or even weeks. The first signal is actually a cloud cost spike at the end of the month, and by then you're debugging something that's been happening for several days or even weeks. The third one is the one that nobody wants. A B2B customer sends you a screenshot, video, or just plain email about their SWOT dashboard before anyone on your team noticed anything was wrong. All of these have the same underlying problem. By the time anyone looks, the operational data is gone. Now, here's where it gets more interesting. Valky has been systematically building out the signals it exposes. And these are genuinely new things that Redis never had. Let me go through them quickly because they're worth understanding individually. Command walk. This goes significantly beyond Swalwalk. Swalwalk captures commands that exceeded a walk latency threshold. You can figure a threshold in microseconds, and any command that takes longer than that gets walked. That's useful, but very limited. Command walk separates the dimensions. You can capture commands by CPU time independently, from IO time independently from the total duration. Why does that matter? Because a command that's slow because it's doing a lot of computation looks very different operationally from a command that's slow because it's waiting on I/O. Slow walk can't tell which one you're dealing with. Command walk actually can. SWOT stats, this one is specific to cluster mode and it fills a gap that has existed since Redis cluster launched. In a cluster, your key space is divided into 16,384 hash slots distributed across nodes. If you have a hot slot, a partition of the key space that's receiving disproportionate traffic, you essentially couldn't see it directly before. You could infer it from the overall CPU, maybe from client-side APM, but slot stats exposes per slot operation counts, bytes read and written. and key counts per each SWOT. So now you can say that SWOT 4321 is actually receiving 40% of overrides rather than guessing it. Latency history and latency latest are actually existing in Redis as well, but they're still worth knowing because they give you event-based internal timing, not derived from client measurements, but from inside the server itself. Fork latency for RDB persistence operations, AOF write latency, RDB generation timing. These are the events that cause latency spikes from your application's perspective. And now they are directly measurable from the server side as well. I/O thread metrics. Valky has multi-threaded I/O models. However, this creates an observability challenge. If your instance is saturated, you need to know which thread is the actual bottleneck. Is the main thread CPU bound? Is the I/O thread pool exhausted? From the outside, without thread level metrics, these look identical. Valky now exposes cumulative CPU usage per I/O thread and for the main thread separately. With client no touch and no evict give operators, finer grain control over which connections are protected from eviction, surface through client list. For teams running mixed workloads, imagine background jobs, application traffic, and monitoring agents all on the same instance, this actually matters so you can see which client is doing what exactly. And with 9.1, the release candidate for Valky that dropped earlier this week, things keep going. Cumulative I/O thread usage metrics, cumulative main thread CPU, whole cluster info, and cluster scan. And cluster scan is actually the headline for tuning purposes. It solves a problem I mentioned earlier. Consistent key scanning across all cluster nodes in a single coordinated operation. No more stitching together pair nodes, scan results manually, and trying to figure things out. So the signals are all there. The question is whether anything captures them. Before talking about what good tooling looks like, I want to make a structural point that often gets missed. Developers and operators are not the same user, and tooling that tries to serve both equally usually serves neither very well. I've seen this play out in practice. Redis Insight was positioned primarily as a developer tool. Browser, query builder, data editor, and developers used it. But the usage pattern that showed up in production were often operators, service reliability engineers, database administrators who needed to understand what the instance was doing, not just what data was in it. The interface wasn't built for that use case, and it actually showed. So let's try to separate them properly. Developers are writing application code against Valky or Redis. Their feedback loop is tight. During the build cycle, they want to know, is this key's access pattern efficient? Am I accidentally doing n+1 lookups? Is this pipeline structured correctly? For this persona, friction is the absolute enemy. An IDE native experience, a CLI tool, an MCP protocol, or anything like that shows you your command patterns without leaving your editor is more likely to get used than a separate monitoring dashboard that requires a context switch and constant alt and tabs. Pattern analysis matters more than single command tracing. They don't care about this command was slow, but the interesting is this pattern is always slow every time it's called from this code path. So this code path in this command can be optimized. Critically, the aim is to be useful before a problem, not just after. The developer feedback loop is where you catch bad patterns early, before they're running at 10,000 requests per second in production. Operators, on the other hand, are running Valky in production. Their job is reliability, and their feedback loop is slow and oftentimes asymmetric. Everything is fine until it suddenly isn't. And that isn't is usually in the middle of the night. So, real-time dashboards are table stakes. The more important requirement is historical persistence and data. The 3 a.m. scenarios I described only has a resolution if something was already capturing command walk and small walk data while the incident was happening. Correlation is the other key requirement. A latency spike alone is not informative. A latency spike that coincides with the memory usage increase and a shift in command patterns, that's a root cause. The tooling needs to hold multiple signals in the same view aligned on the shared time axis. Persistence isn't a nice to have. It's the difference between having a post-mortem and having a guessing game. And here's what both personas share. They need tooling that treats operational data as worth keeping. Common patterns, latency events, connection behavior. This is diagnostic gold. The problem isn't that the signals don't exist. The problem is that nothing actually captures them before they're gone. And for teams running Valky specifically, there's a second layer. The tooling needs to actually know what Valky exposes and why it matters. Command walks, SWOT stats, IO thread metrics don't exist in Redis. Running a Redis-oriented tool against a Valky instance and surfacing none of them isn't a minor gap. It's leaving the most operationally useful signals completely untapped. At this point of time, Valky is roughly 2 years old as a production project, and the observability work is in recent releases is not accidental. The maintainers understand the gaps. So, what to watch for? Prometheus native tooling built against Valky's actual info surface, not Redis's. Persistent capable tools that treat command walk and SWOT stats as something worth keeping. IDE native experiences that meet developers where they actually work and live. Cluster-aware key analytics that take advantage of cluster scan from the new release candidate, and tooling that actually uses every new primitive that Valky provides with each new release. The signals are there. The window to build on them is right now, before the ecosystem calcifies around Redis compatible tooling that misses half the picture. Thank you for listening. Happy to take questions, and you can find me at the links on the screen. I'll be more than happy to hear your pain points and anything that I might have missed. Thank you so much. Bye.